Okay, so if you've been watching these videos in order, you have made it to the last one of section 2.4. Yay! It's a long section, but we're getting there. So the coefficient of variation helps us to describe the standard deviation as a percent of the mean. So let's write that here, the coefficient of variation. We often abbreviate that as CV. Woo! A data set describes the standard deviation as a percent of the mean. Okay, so just like before, we've got a population formula and a sample formula. So for the population, we have the coefficient of variation is equal to sigma divided by mu. Sigma divided by mu times 100%. For a sample, the coefficient of variation is equal to S divided by X bar times 100%. That's all it is. So we know how to get mean. We know how to get standard deviation. Let's take this and do one final example for this section. Let me make sure my word problem is up. There it is. Insert screen clip. Okay. Yeah, there we go. Okay, the table below shows the population heights. Ooh, that's a key word there. Population. That's important. Population heights in inches and weights in pounds of the members of a basketball team. Find the coefficient of variation for the heights and the weights. Then compare the results. Okay. So, I'm going to... The good news is, if you've made it all the way through this section, you are tired of calculating things by hand. So the good news for this one is we're going to do a lot of stuff in the calculator. So I'm going to make a note here for those that are just trying to look at the notes. See video for calculator steps. Because we're going to do most of this in the calculator. Heights. Nope. Over there. Weights over here. Okay. So I'm going to bring up my calculator. I'm going to do like I've done previously, and that I've shown y'all previously. We're going to create a spreadsheet. I'm going to put the heights in A, the weights in B. That way I can just put all the data in. 72, 74, 67, 76, 74, 69, 72, 78, 70. There's one hiding behind my calculator. That's a 68. Okay, so those are my heights. Now I'm going to do the weights. 181, 168, 225, 201, 189, 192, 197, 162, 174, and the one hiding is a 171. There we go. Okay, so in column C, I wanted to analyze my heights. To do that, I'm going to hit Menu, Statistics, Stat Calculations, and then one variable stats. There are, I wonder what happens if I put a 2 here. We're going to experiment. Heights, weights, sure, column D. Let's see if it, does it do them for both? Oh, that's cool. Okay, so if you're like, what the heck did he just do? Okay, so what I just did, I'll walk through the menu steps again. I went to Menu, Statistics, Stat Calculations, and one variable stats. But I told them I want the stats on 2 lists. What 2 lists? Height and weight. So I put a 2 here, and it did both the lists for me at the same time. How cool is that? Or maybe I'm just a nerd. Either way, that's cool. Okay, so let's take our values here. I'm going to screenshot this because I want it. Insert screen clipping. I want this. I put it, come on. This can go away. That can go away. Okay, so if I look at what this is telling me, column E is going to be for my heights because that was my first variable. So this one is height. This one is weight. Okay, now, what did the problem say? The problem said population height, population weight. So for my height, my mu, the mean, is 72 inches. The standard deviation, it told me, was 3.37639. Okay. For the weights, or this is also in inches. For the weights, the mean was 186 pounds. And the standard deviation was 17.9053 pounds. So the way we get coefficient of variation is we divide the standard deviation by the mean. So I'm going to say CV with the subscript H for height, or HGT. That would be the 3.37639 divided by 72 times 100%. So that would be roughly equal to, well, let's see. Now, one thing you may not realize, at least on these Inspires, is that you can store values. Like this value right here, I know it's important. So I'm going to store this as an H. So I can use it later. I'm going to hit enter. Cancel. Okay, I can't do that. Take that back. I can't do that. cancel. But what I can do is this works like an Excel spreadsheet. So I can, and you know what, heck with that. We've got our numbers with as many decimal places as we have, we're Gucci. I'm going to just go here to the scratch pad and type in my values. 3.37639 divided by 72 times 100. 4.69%. Okay. 4.69%. Okay, now we need to do the coefficient of variation for the weights. 17.9053 over 186 times 100%. It's going to be approximately, let's see. So 17.9053 divided by 186 times 100. 9.63%. 9.63%. Okay. So there's our coefficient of variation for both of them. Now, what does this tell us? That's the million-dollar question here. Like, what is all of this telling us? Since the CV for height is 9.63% as compared to the CV for weight, which is 4.69%, we can say that the heights are more variable than the weights. The higher the coefficient of variation, the more variable the data. The weights had a higher coefficient, therefore that means the weights are more variable than the data, than the heights. So that's what coefficient of variation tells us. It tells us which data varies more than the other. Okay, that's it for section 2.4. We have made it through the bulk of chapter 2. We have one more section left. But in the meantime, remember, you are loved, you are created to do wonderful things, and you are awesome. Always believe.